In this podcast, we're going to be looking at some features of the graphs of polynomial functions. First thing we're going to look at is multiplicity and x-intercepts. Multiplicity is the number of times a factor appears. So if r is a 0 of even multiplicity, then the graph is going to touch the x-axis and turns. Right? So it's going to touch the x-axis and turns around at r. So anytime we have a factor or solution that appears twice, or 4 times, or 6 times, our graph is not going to cross. Our function is not going to cross the x-axis. Instead, it's going to touch the x-axis and turn around back the way it came. And if r is a 0 of odd multiplicity, then the graph crosses the x-axis at r. So if our factor or solution appears once or 3 times, we're going to cross. So below here, we have sort of a rough sketch of y equals x plus 2 times x plus 2 times x minus 2. And we see we have 2 factors of x plus 2, so we could rewrite that as x plus 2 squared. So here we look at the graph. Notice that negative 2, because our x-intercepts are x equals negative 2, right? We said x plus 2 equal to 0. Solve for x. We have x equals negative 2. At negative 2, our graph touches and turns. Right? It does not cross the x-axis. So right here, okay, we touch and turn. That says turn. There we go. And then here at x equals 2, we cross. That's because we have multiplicity 2. We have 2 factors of x plus 2, or two solutions of x equals negative 2. And we only have 1 solution of x equals 2. So we're going to cross where we have 1 solution and touch and turn where we have 2 solutions. All right, so anytime it's even, we touch and turn. Anytime it's odd, we cross. Zeros and roots. If the coefficients of a polynomial p of x are real, then the x-intercepts of the graph y equals p of x are real zeros of p and p of x, and real solutions are roots for the equation. All right, so here we have a graph, and we see it crosses 1 time. We have 1 x-intercept. This is a cubic function. We can see the equation right there. We have 1 x-intercept, and that is x equals 3. How many solutions should we have for a cubic function? Well, the solutions is the same as the degree. So our function here is degree 3. We should have 3 solutions, and we only see 2, or excuse me, only see 1. Have 3 solutions. Okay. So what are our 3 solutions? Well, we have 1 real solution at x equals 3. Therefore, we have 2 imaginary or complex. So we have 2 complex imaginary solutions. Our complex solutions always occur in pairs. If we only cross the x-axis once, and how do we know, by the way, that that doesn't count for 3? We're not crossing it there for 3. We don't have 3 of the same factor. And that's because we know because we turned here. So if you notice right here, we have this turn in the middle of nowhere. It's not from crossing the x-axis. We just turn. Right? That turn indicates complex solutions. And that's how we know this is not 3 of the same factor. Let's find that missing factor, okay? Or missing solutions, I should say, not factors. We're not going to be able to factor this one. All right, so we're going to use Our equation is f of x equals x cubed minus 6x minus 9. If you notice, there's no x squared term. So let's rewrite that and fill in 0 as the coefficient for x squared. So we have x cubed minus 0 or plus 0x squared. It doesn't really matter whether it's minus or plus. Minus 6x minus 9. Well, we know we have one solution, x equals 3. So we're going to use that one to reduce our equation and find the other two. Okay, so 1, 0, negative 6, negative 9. We'll bring down the 1. 1 times 3 is 3. Add, we get 3. 3 times 3 is 9. Add, we get 3. 3 times 3 is 9. Add, we get 0. All right, so now we have x squared plus 3x plus 3 equals 0. And, well, there's nothing that multiplies. 1 times 3 is 3. Nothing that multiplies to give me 3 and adds to give me 3. So we're going to use the quadratic formula here. We could use completing the square, but I'm going to use the quadratic formula. Okay. So we have x equals, and the formula is negative b plus or minus the square root b squared minus 4ac, and that is all over 2a. Hope I have enough room here. I might have to move this over here and move this over here. There we go. A little cramped, but that fits. All right. So I'll plug in. We have x equals negative 3 plus or minus 3 squared minus 4 times 1 times 3. And that's all over, give myself a little more space, 2 times 1. All right, so now we'll simplify that. So we have x equals negative 3 plus or minus 9 minus 4 times 3 is 12, times 1 is still 12, all divided by 2. So x equals negative 3 plus or minus negative 3 divided by 2. Don't forget to simplify your negative. X equals negative 3 plus or minus I square roots of 3 over 2. So now we found our other two solutions. So we have three solutions. We have the real solution, x equals 3. And we have the complex solution. Squeeze that in here. Maybe I'll write in a different color so you can see it. X equals negative 3 plus or minus I square roots of 3 over 2. Right? And that's our two complex solutions, because we have plus or minus there. Okay? All right, so here where we cross, we have a real x-intercept where we just kind of have this turn, and we didn't just cross the x-axis. We know we have two complex solutions. All right, we're going to complete this table, and we're going to match the equations with, or complete this page. We'll match the equations with the graphs. So we're going to answer a few questions here. First of all, and be thinking of the answer yourself. I know I can't just ask you the question because you're not here, but you could think of the answer as I ask them. So first thing we want to know is what's the degree here? Is it odd or even? Well, this is definitely odd degree. And if you weren't sure, we can tell it's an odd degree because the ends go different directions. On an odd function, one end goes up, the other end goes down. Different directions. All right, so we know we only have, if you look at the bottom here, all of our equations are either cubic or quartic. We have 1, 2, 3, 4 solutions on number 1 there. 3 has 1, 2, 3. 2 has 1, 2, 3. And 4 has 1, 2, 3, 4. So the degree is odd. Our leading coefficient, is it positive or negative? Our leading coefficient is positive. excuse me, negative. I was thinking negative and wrote positive. It's negative, and that's because it goes, our function goes down left to right. Right, so we have a negative leading coefficient. Let's find our x-intercepts and change them to factors. All right, so we have our x-intercepts. Our x equals -3 and x equals 1. If x equals -3 is a factor, remember the factor and the solution have opposite signs because you set your solution, set your factor equal to 0 and solve for x, which means you're going to add the opposite to the other side. So our factor is going to be x plus 3 and x minus 1. Now I only see two solutions, but one of our solutions counts twice. If you notice here, we touch and turn, that's a multiplicity of 2. Where we crossed, that's multiplicity 1. All right, so that means we have two factors, excuse me, one of those days, two factors of x minus 1. And so that means we have a negative leading coefficient. We know it's -1, by the way, because that's our only option in our equation here on our choices. If we didn't know the equation, or didn't have a bank to choose from here, and we were just solving for our a value, we would do it just like we wrote the equations of the quadratics. We'd plug in a value, we'd have our equation in factored form, plug in a value for x and y, and then solve for a. Here we only have one choice, it has to be -1. So our equation, therefore, is going to be f of x equals negative x plus 3, x minus 1 squared, which is, well, in a different order, but is the exact same thing as 3. If you want, I will change the order and put the squared one first, so it matches the equation down below. All right, let's look at the second one here. All right, so our degree, even or odd. This one is even. Both ends go the same direction. All right, so leading coefficient. Our leading coefficient is positive because both ends go up. All right, so now let's figure out our x-intercepts. We have x-intercepts at -3, x equals -1, and x equals 2. We'll change those to factors. All right, so if x equals -3 is the solution, x plus 3 is the factor. If x equals -1 is the solution, x plus 1 is the factor. And if x equals 2, x minus 2 is the factor. And now we have to figure out our multiplicity. Right, so here if we look, we've got, the same color, I guess. That x-intercept right there is multiplicity 1. We crossed. Same thing over here. Those are both a multiplicity of 1. But right here where we touched and turned, this is multiplicity 2. We have two factors of the x minus 2. So we'll write this, and I'll write it in the same order as the answer. Our answer is number 1 here. F of x equals x plus 3, x minus 2 squared, and x plus 1. Okay. And notice our a value is +1, which is the reason our function has both ends going up. Let's do the third one here. All right, so our degree, even or odd. This one is even. and that's because our ends go the same direction. Leading coefficient is positive. Both ends go up. All right, our x-intercepts. We have only two. X equals -3 and x equals 2. If -3 is the factor, then -3 is our x-intercept, then x plus 3 is the factor. If 2 is the solution, then x minus 2 is the factor. And notice we touch and turn on both, so multiplicity of 2 on that one, and multiplicity 2 on this one, which means that those should both be squares, and that means our equation is going to be 4, which is f of x equals x minus 2 squared, x plus 3 squared. And the last one, our degree is odd. Ends go opposite directions. Our leading coefficient is positive because the graph goes up left to right. All right, our x-intercepts. X equals -4, x equals 1, and x equals 4. We'll change those to factors. So if x equals -4 is the x-intercept, x plus 4 is the factor. If x equals 1 is the x-intercept, x minus 1 is the factor. If 4 is the x-intercept, x minus 4 is the factor. And notice we cross, cross, cross. So these are all multiplicity of 1. This one, oops, kind of pointing the wrong direction there on my arrow. This one, and this one. They're all multiplicity 1 because we crossed. So our equation is just 2 there. If you want to change the order so we can it matches, we can. F of x equals x minus 1, x minus 4, x plus 4. Really, the order you write the factors in doesn't matter because multiplication is commutative. The order doesn't matter. All right, I will post the last thing, which is the problems for you to solve. It's these problems right here. Make sure that you not only solve but justify your answer. On 69, it's asking for the equation in standard form, which means after you write it in factored form, you have to multiply to put it in standard form. And also wanted to let you know that on tomorrow's test and formative, you may have a note card with some, especially for the test, with some formulas. The test is on graphing quadratic equations, formulas, examples, whatever you want. You get one note card, all right? So I figured I'd say it on the podcast too. So those who listen to the podcast would know that in advance, and I'll also post that information. All right, so see you in class, and we'll be looking more at polynomial functions.